Before we begin our multiplication counting principle lesson, let's remember that probability is the number of outcomes where an event occurs divided by the number of outcomes in the sample space, assuming that each item in the sample space is equally likely to be selected. If I'm going to be dealing with, let's say, 36 dice rolls, I could write out the whole sample space and then go ahead and circle, which is what we did in our probability intro lesson. I could deal with a deck of cards. I can physically go through the deck of cards and say these cards are here and these cards are here because there's only 13 face values times 4 suits, which makes 52 cards. We started having countouts where we're in the 40,000s. That was our entree problem. And now we're going to start working our way even to much larger numbers as we focus on probabilities of lotteries. And that I don't want to, write a program for so that it will literally list all of them and then go through the list. It's nice, but we should be able to do this just using some general mathematical rules. And one of the things we need to work on is the without replacement situation, where once an item is used, you can't use it again. Because there are two very specific types that we want to look at. There's the permutation and there's the combination. And the main difference is where order matters or doesn't matter. See, a permutation is the number of arrangements of items without replacement when order matters. So I have my example here. I've got Anna, Bob, Cal, and Dan, and they enter a local essay contest. And the question is, how many possible ways can the judge select first and second place if no ties? So if I wanted to say Anna, then Bob, that means Anna is going to come in first, Bob will come in second. If I had said Bob, Anna, Bob coming in first and Anna coming in second, those are two very different outcomes. One of those are going to be a little happier than the other individual because they took first and not second. Therefore, those are two different permutations because, again, order matters. So I'm going to actually go ahead and figure this out, and the easiest way to do that might be as simple as the multiplication counting principle. That's where you go, all right, how many people could have taken first place? And in this case, I would have gone and said, well, there's only 4. Now, once I'd chosen first place, and then I said, okay, so who's left to take second place? There would only be 3 individuals, meaning 4 times 3 is 12. That's the multiplication counting principle. What I want to show you is that this is also known as a permutation, and we can write that as NPR. N is the number of objects. For this particular problem, we have 4 objects. I'm sure the individuals don't want to be considered objects, but we do have Anna, Bob, Cal, and Dan. And then when you do a permutation, it's taken R at a time. Basically, how many are we taking, okay? And in this case, we're going to say R is equal to 2 because we only have 2 places that we're going to. So once again, N is where it's essentially where you're going to choose from, and R is how many taken. Okay. And so if I was going to compute NPR, I would be typing or writing down 4P2. Now I can also write that in a little older notation, or alternate notation, that would be a better way of saying it, P parentheses 4 comma 2. That's also the same as 4 factorial over 4 minus 2 factorial. But see, that's where I'm jumping ahead a little bit because that actually is the answer to what I was looking for down here. The formula for NPR using factorials and division. I'm going to put my 4 up here, and then I'm going to go 4 minus 2, and I'm going to close the parentheses and put factorial. Remember, it is not a distributive type of operation, so I can't do that. So how would I figure out what 4P2 is? Well, on the calculator, what I would be using is I would be typing in my 4, I'd be going to math, and then I'd be going to the probability menu, which is over here, and you'll notice I have NPR. So if I choose number 2 there, I can go for NPR2, and I would come up with 12. So there is where I get my 12. But I didn't need a calculator to do the following. I could have gone 4 factorial over 2 factorial, and then what I would have done is I would have written this out as 4 times 3 times 2 times 1 all over 2 times 1, and I would have gone ahead and canceled those out, and I would have still came up with 12. Just go ahead and write that down, 12 permutations. There we go. Now, I'm going to demonstrate this by actually writing out all the possibilities, aka the sample space. And I'll just use the first letters. So one of the possibilities could have been, in this case, it could have been AB, it could have been AC, and AD. In all three cases where Anna takes first and three other individuals take second. But if Bob took first, it could have been BA, BC, BD. Cal could have gone first, but then that would have been CA, CB, CD. And then finally, Dan may have taken first, and the other options are DA, DB, DC. And that's it. Those are all 12 possibilities. It wasn't that hard to write out all the possibilities, but understanding how permutations work is important. So I'm just going to give you a heads up. All three of these notations, or three of these bullet points, are things I'm expecting, meaning I might ask you to explain how you came with the answer, not what is the actual number, but how did you do this using the multiplication counting principle? Or how would you write this using a permutation? But I will also tell you that another popular question is, how do you write a permutation using factorials and division? So you could write it as 4 factorial over the quantity 4 minus 2 factorial, or just simply 4 factorial over 2 factorial. Be prepared to use all three methods. Now, a permutation is different than a combination because the permutation, the order matters. For a combination, order does not matter. So let's go back to the essay contest, okay? And it says 2 finalists will go to the statewide essay contest. How many possible ways could the 2 finalists be selected? Here we're not making an emphasis on who took first and who took second. We're just selecting 2 individuals to go to this competition. So if I said Anna and Bob, or I said Bob and Anna, it really wouldn't have made any difference how they were said because it's the same group of people. So when you think of combinations, okay, I really would emphasize that you think of the word group. Okay? And the only reason I'm going to change that color is because we just had red here, and I don't want that to be confused. So when you think of combination, think of groups, where order does not matter. So in this particular case, I'm going to simply go, the notation was, let's say 4C2, which in this case, on the calculator, would go 4 math over to probability, oops, too far, and then down to number 3, and then type in 2, and you're going to find out that there's only 6 combinations compared to when there were 12 permutations. And the formula for NCR is actually, all right, NPR. So in this case, you could have written it as 4P2, but then what you do is you divide by all the different ways those were ordered and then end up being the same group. So in this case, 2 factorial. Or if you want to write it a little differently, it would be 4 factorial over 4 minus 2 factorial, where this is that part of the formula. But then you just have to divide that also by an additional 2 factorial. And either way you get that, you get 6 combinations. Well, if I was actually writing that out, I could write AB, AC, and AD, but I would not write BA because that one would have already been used as AB. So I could go BC. Remember, you can't go BB because the whole point of combinations and permutations is that you have without replacement, and therefore you can't use the same letter twice. And I could go BD. I can't do CA because that's there. I can't do CB. I just did that. So the only other possibility is CD, and that's how I end up getting my 6 possibilities. Let's continue looking at permutations and combinations with the following examples. A website requires a 3-digit password consisting of letters that cannot be repeated. how many passwords are possible. We'll begin by recognizing that that phrase right there essentially tells me that we are doing a without replacement type problem. And another fact I'd have to realize that if I was typing in a password, ABC is not going to be the same as if I had typed in a password as CBA. So what that implies is that order matters. So before I just get right to the answer, please understand, I may have the expectation of you demonstrating how to do the problem in multiple fashions. Maybe we'll start off with the multiplication counting principle, and we'll just simply say 26 times 25 times 24. 26 letters, then followed by 25 letters, followed by 24 letters. Maybe I'll have you demonstrate a permutation just by writing it as 26P3. I had 26 letters to choose from. I took 3 at a time, and I chose permutation because order matters. Maybe I'll have you demonstrate using factorials, because you'll know that the permutation formula is 26 factorial over 26 minus 3 factorial. N factorial over n minus r factorial. In fact, maybe that's what I should do here. Maybe I should just write the formula here to re-emphasize that part of the knowledge. So there you go, I'll put that there. Now, you don't have to write 26 factorial over the quantity 26 minus 3 factorial. You could actually just do the quantity and say that's 23 factorial. Let me also emphasize again what a factorial means. It means 26 times 25 times 24 times 23 times 22. You get the idea, so I'll go dot, 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 times 2 times 1. So down here, I'm going to go 23 times 22 dot, 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 2 times 1. Realize that these cancel out, and this ends up looking exactly like our multiplication counting principle. In the end, there were 15,600 different ways, be it that you typed it in as, come on, there we go, 26 P3, or 26 times 25 times 24, or going 26, hit the math, come over here, choose number 4 for factorial, divided by parentheses, 26 minus 3, close the parentheses, math, and then number 4 factorial. Any of those possibilities would still get you the correct number of permutations. Let's look to our second problem. How many 2 topping blends can be added to your ice cream if there are 12 to choose from? Okay. Well, if you're going to have 2 different toppings, once you choose it, it will be without replacement. All right. And just for future reference, I'm going to use the abbreviation WO for without replacement. However, traditionally, when I say I'm putting toppings on, let's say, ice cream or pizza, it really doesn't matter the order of how they were put in traditionally. It's just like those are my 2 toppings. So in this case, order does not matter. Order does not matter. And that means what we have here is a combination. So when it comes to combinations, one of the things I'm going to focus on is I would expect you to show me the combination way of doing it, which in this case is there were 12 toppings, and it would be 12C2. But I also want you to understand that the formula, okay, for combination is n factorial over n minus r factorial. And this part right here is the 12P2. The only difference is it's being divided by an extra 2 factorial. Or you could say 12 factorial over 12 minus 2 factorial, 2 factorial, or 12 factorial over 10 factorial, 2 factorial. And any way you get this, you got 66 possibilities. The principal is selecting a committee of 5 students out of the 8 that applied. How many different ways can you pick that up? All right, we're going to get right to the heart of the matter. This is a combination because it's a committee. All right, committee out of 5 students doesn't seem to have any necessary order. If I was picked 3rd or 5th, I'm still part of that same committee. There is a total of 8 ways of doing this. I'm choosing 5 students, so it could be written as 8C5, which in this case is 8P5, just divided by an extra 5 factorial, because all the different ways I could do a group, A, B, C, D, E, could have been A, B, C, E, D, A, B, D, C, E, and I could do that 5 factorial ways, 120 different ways of those being permutations, but all those permutations are the same one, so we want to eliminate that. And that would mean that you're taking 8 factorial over 8 minus 5 factorial, 5 factorial, and 8 factorial, that's the same as being divided by 3 factorial, 5 factorial. The reason I keep emphasizing this is something that's going to come up later, and that's why I'm going to keep, emphasizing it, since I literally just said that. And that ends up being 56 possibilities. Compared to down here, where it says a startup band has earned an opportunity to play 4 of their own 11 songs at the local music festival. They're creating a specific playlist of a certain type of order. The fact that there's order involved makes this a permutation. Are they going to start off with their best song? Are they going to save their best song for last? They have 11 songs. They're choosing 4 of them. And so you might use the multiplication counting principle, 11 times 10 times 9 times 8. Maybe you're going to just simply say, okay, how do I write that? Well, I could do 11 factorial and just realize that starting at 7, okay, 6, 5, 4, those are all canceled out. Now, I would have realized that because I would have gone 11 minus 4 factorial, or just simply say 11 factorial over 7 factorial. And in that case, you would have came up with 7,920 different possibilities. We will conclude this part of the multiplication counting principle video with this particular page, which focuses on properties of permutations and combinations. And in the process, I'm going to talk about a very key aspect of the definition of factorial. And we'll begin with our example where we have 31 students participating in an activity up on the stage, which means I'm going to have 31 students to choose from. And if I'm going to have the number of ways students can line up from left to right, I have to understand that a student can't be on the far left and the far right at the same time, so that makes it a without replacement. A student who's to the left of, let's say Alice is left of Bob, Bob is left of Alice, that would be a different lineup, which means order is going to matter. That's why we have a permutation, and I'm taking my 31 students and I'm taking all 31 at a time. So if I treat it as a multiplication counting principle, where I go 31 times 30 times 29 times 28, and I keep doing this until I go times 4 times 3 times 2 times 1, I would have essentially written out everything as the long way of doing a factorial, 31 factorial. So let's get right to the heart of the matter. NPN. When you take all the objects that you have at the same time and order matters, you get n factorial. But what I want to focus on right now is what would have happened if I actually had done the formula for 31p31, meaning I would have gone 31 factorial over 31 minus 31 quantity factorial, which is the same as 31 factorial over 0 factorial. Let's write that for the more generic property up here. NPN is n factorial over n minus n factorial, which is the same as n factorial over 0 factorial. The question is, what is 0 factorial? And 0 factorial is not defined the same way this is, because we start with the largest number, 31. We count down by ones each time, multiplying each one as we go along until we get to 1. If I started at 0, I'd have to be counting up. Also, 0 times anything would be 0, and then I would have a dividing by 0 process. And so the easiest way to understand is we had, as mathematicians, defined 0 factorial because of the math to be a very specific situation, and 0 factorial by definition is simply 1. And so let's make sure we have that nice and clear up here. 0 factorial is defined to be 1. Let's continue on with a few more properties. I'm going to have my 31 students, but I decided that I don't need 1, so I'm going to hold 1 student back. And yet I still want to know how many ways can I line up 30 of the 31 students up on stage. Well, if I do the math, it's 31 times 30 times 29 times 28 times dot, 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 times 4 times 3 times 2. How is the answer going to be different just because I didn't write times 1 there? It's not. And so at this point, 31p30 is also going to end up being the same as 31 factorial. So what I guess I'm also trying to tell you is it doesn't matter if you take all the objects that you could choose from or all the objects minus 1 from it, they're both going to be, in this case, n factorial. npn is the same actually as npn minus 1. Now, if I was only going to have 1 student out of the 31 win a prize, I really don't need to do much for the multiplication counting principle because literally I would only have to write 1 blank and it's 31. So when I'm only choosing 1 item from n objects, I'm only going to have n possibilities. At the same time, if I'm going to have 0 winners declared, meaning none of you are winner. You didn't win, you didn't win. Let me just scoot this up a little bit. And I said, how am I going to choose no winners? Well, if I actually did the math, and I would have gone 31 factorial over 31 minus 0 factorial. Now again, I'm not talking about this 0 factorial because it's not distributive. I'm saying literally it's 31 factorial over 31 factorial. Well, we know those are going to cancel out, and that leaves you with something. It leaves you with 1. Yeah, 1 way. Nobody wins. And so anytime you take nobody from a list of objects, you're always going to have at least 1 way of doing that. So those are sort of the permutation properties. Now I'm going to finish up by doing the combinations. And for that, I'm going to need groups. And so what I did is I took 5 players and I decided to divide them up into 2 teams. All right? And what I'm going to ask is first is how many ways can a 3-person team be formed? And so we have without replacement, either a person on this team or that team, but they can't be in both. It doesn't matter where they got selected on the team, they're part of the team. So this would be a combination, and I'm just going to simply say 5C3. And if I do that on the calculator, and I go 5 math, and I come over here to probability, and I choose 5C3, and I enter, you'll see I get 10. So over here, what I'm going to do is quickly write out all 10 possibilities. I could have A, B, C, A, B, D, A, B, E, A, C, D, A, C, E, A, D, E. Now that involves all my groups that could have been with A. So let's focus with more groups that involve B, B, C, D, B, C, E, or B, D, E. And then finally, there's one last group, C, D, E. So there was literally 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possibilities. Well, here's where it gets a little interesting. Okay. If I ask you how many 2-person teams there are, and I would have gone 5C2, so let's just go up here, let's change the 3 to a 2, you will notice I also get 10. How is that? The reason is again, let's look at the formula of what does it mean to be 5C3. 5C3 means it's going to be 5 factorial over 5 minus 3 factorial, but then I divide by 3 factorial, which is the same as 5 factorial over 2 factorial, 3 factorial, with the 2 and the 3, the 2 factorial, 3 factorial in the denominator. If I was to do 5C2, I would have gone 5 factorial over 5 minus 2 factorial. But 5 minus 2 factorial is 3 factorial. And then I would have divided it by 2 factorial. So you will see that these denominators are the same. And because they're the same, when I form a 3-person team and I essentially make that group, I have also just made a group of 2 players. I have made a group of the DE team because that's all that's left for the other team. I've made a CE team. I've made a CD team. Here I make a BE team. I make a BD team. Here I have a BC team. Here I have an AE team. I have an AD team, an AC team, and finally an AB team. And that's one of the neat things about combinations. Think of it simply as this. You have whatever numbers you have, whatever team you decide to form, be it 9 players out of 15. If you make a 9-player team, you've just essentially made a 6-player team, those that did not get selected for the 9-player team. So as I do these particular problems and I say, okay, what is NCR? Just remember, NCR is actually NCN minus R. Or in this case, 5C2 is the same as 5C5 minus 2, which is 5C3. So as we continue on with this, how do I do a 1-person team? Well, to be honest, it's not going to be that different if it's a 1-person team and we think of it as a combination or a permutation. There really is only 5 choices to pick from, okay? If you wanted to do the math, it would be 5 factorial over 5 minus 1 factorial, which then would be divided by 1 factorial, which is 5 factorial over 4 factorial, leaving me with just 5 after I go 5 times 4 times 3 times 2 times 1, divided by 4 times 3 times 2 times 1. There's only one way to choose. You're going to have n ways of doing it. And it doesn't matter if it's permutation or combination, because when you only have 1 person, do we even care about order? Okay? And just to give you a hypothetical of how this would play out, my team could have been simply as, I could have had for a 1-player team, I could have had A, B, C, D, E. Let's move that down to here. Okay? I could have set up a team that was literally 4 players. B, C, D, E, A, C, D, E, A, B, D, E. I could have gone A, B, C, E, or I could have gone A, B, C, D. And so that's why when I said, how many ways could I have a 1-person team? It was n. How many ways could I have had a 4-player team? Well, 5C4 is the same as 5C1, which is 5. And so this and this are both n ways of doing it. And if I am going to have a 0-person team, meaning I'm going to have 5C0, now if I go 5 factorial over 5 minus 0 factorial divided by 0 factorial, then I will have 5 factorial over 5 factorial 0 factorial. These will cancel out. That would mean it's 1 over 0 factorial, but I already know that's 1 over 1, which means it is 1. And so once again, if you do not select anybody from the group, be it permutation or combination, there is one way of doing that. And so literally if I don't select anybody and I have the null set over here, then my other team will be a cooperative A, B, C, D, E team. And so 5C5 is the same as 5C0, which is 1. And so NCN is not the same as permutations, because NPN, as we saw up here, was n factorial. NCN is the same actually as NC0. There is one way of selecting a team of everybody. And so those are the permutation and combination properties, and that hopefully gives you a better understanding on what happens when you might have a without replacement situation, and you can determine if order matters or order doesn't matter. If order matters, permutation. If order doesn't matter, combination. And just remember that we have been learning the factorial. We now know that also 0 factorial is defined to be 1.